Today we're going to do 10.5, apply other angle relationships in circles. Our objective is to find a measure of angles inside or outside of a circle. What is a measure of an intercepted arc? We know that. The measure of an intercepted arc is what? If this angle is 30, what's the arc going to be? The inscribed angle's half the arc it intersects. So what's it going to be? This is 30, this is 60, right? Okay, what happens if I change it so that one side is tangent to the circle? Okay, so if it's tangent to the circle, like that, all right, it's still going to be half. Now your intercepted arc is this arc. It's still half that arc. If a tangent and a chord intersect a circle at a point, so here's the tangent, there's the chord. If they intersect a circle at a point on the circle, then the measure each angle formed is half the measure of the intercepted arc. This part that's cut off from the rest of the circle, it's half that arc. Everybody got it? Example. We have to find the measure of angle 1. Okay. So we still have, it's, you know, in the previous explanation they talked about this arc, right? But we could also say this still fits the definition of this arc right here still fits the definition of it's cut off by it's made by a chord and a tangent. Here's the chord. We've got the chord and we have the tangent. So if this is 284, what's 1 going to be? Half of 284. Yeah. So that's going to be 142. So angle 1 equals 142. Questions? All right. The angle inside the circle theorem. If two chords intersect the interior of a circle, then the measure of each angle is half the sum of the measures of the arcs intercepted by the angle. So that's saying that it would be, I would take AC plus BD and divide it by 2. Rather than multiply by 0.5, I like it better to say the measure of angle 1 equals AC plus BD divided by 2. Right? You take it by. So you add these two together, divided by 2, that's going to be this angle. And if I wanted these angles, I'd add these two arcs together, divided by 2. Or I could do linear pair. Let's look at an example. So on this problem, okay, angle 1, the angles intercept those arcs, so we say 58 plus 72 divided by 2 equals, so that's going to be 58 and 72 is 130 divided by 2 equals 65. That angle would be 65. It's the average of the two angles. All right, and any questions? Okay. Now, angles outside the circle theorem. In this case, I've got this angle 1 is outside the circle. And it's formed by a tangent and a secant. All right? Then now we have the two intercepted arcs by those lines are, we have this arc and this arc. Those two arcs intersect. Okay? Not intersect. Those two arcs are intersected by these lines. Everybody see that? How this starts here, where this, and it goes to B, and then from A to this point C. What you're going to do now, rather than add them, you're going to subtract them. So it's going to be BC minus AC divided by 2 equals angle 1. If it's outside the, if the angle's outside the circle, you subtract. If the angle's inside the circle, you add. Questions? All right, let's look at an example. All right. So we have this problem here. We've got, so my intercepted angles, maybe you want to highlight them or something. It's this angle and that angle are contained by the lines, okay? So what do I have to do first before I can subtract? What do I have to do? What's missing? This arc, right? The red line? I've got to figure out what the red line is. How can I do that? Gage, how can I figure out the red line? Brandon?
Would you multiply the 134 by 2?
No. Wouldn't multiply 134 by 2. We have to do. We have to go all the way around the circle, right? It's 360. So from here to here would be 34 and 12. So from here to here is 146. Add these two added together. We have to figure out what the rest of the circle is. So we take 360 minus 146, and we get 214. So the red is 214. Now, how would I figure out angle 1? According to my rule. Gunnar, how do I figure out?
You do 214 minus 134.
Yeah, very good. 214 minus 134 divided by 2. So that the difference between those is 80. So that's 80 divided by 2 equals 40 degrees. Angle 1 is 40 degrees. Questions? Okay? All right. Again here, I would write this as measure. I would write this as a measure of angle 1 equals BD minus AC divided by 2 instead of 0.5. This is very similar to what we just did. We had a secant and a tangent. Now we've got two secants. So it's whatever inside the mouth of this angle. So the two arcs now we're dealing with are BD and AC. Those are the two arcs that are contained within this angle, right? So it's the same idea. It's the angle's outside the circle, so I subtract. BD minus AC divided by 2 is going to give me angle 1. Oh, I should say BD, I'm sorry. I should say BD, not BC. BD minus AC divided by 2 equals 1. Angle 1. So here's the example. Right? So it's just a matter of, oh, that bumped and turned on. Turn that off. All right, so we have 92. We have 92 minus 43 divided by 2 is going to be what I have to do. So that would be 49, right? 49 divided by 2, which is equal to 24.5 degrees. All right, any questions on that? Okay, looks like we have some examples now. Oh, okay, there's one more situation here. Now we've got two tangents. Still the same idea. And one is outside the circle, so we're going to subtract. Now we've got inside this angle, inside the mouth of this angle, we've got this arc intercepted and this arc, right? So I'm going to subtract. The measure of angle 1 equals ACB, arc ACB, minus arc AB divided by 2. It's a measure of angle 1. So here's an example. Okay, we have .235 is the, we've got 235, and then this is x, should equal 45. So we would have, when we did this, we'd do 235 minus x divided by 2 equals 45, and then we'd solve, so that would be 235 minus x equals 90. I multiply both sides by 2 to clear the 2 as a fraction. Then we solve for x, so we'd move the 235 over, so negative x equals, we subtract 235 from 90, and we get 145, negative 145, and so x equals 145. Any questions there? No questions. Okay. We've got 4 examples here we can do. All right. How do we find 1? Set it up. Somebody tell me, how would I find angle 1? The angle is inside the circle. Angle 1 is inside the circle. And
102 divided by 2.
102 divided by 2? Nope, we've got, it's not an inscribed angle. We've got these two angles. Those are the two angles. Yep.
Did you do 102 plus 134 divided by 2?
Yes. 1 is inside the circle, so it's 194 plus 102 divided by 2, which is 296 divided by 2, which is equal to 148 degrees. Questions? No questions, okay? Moving on. How would I do this one? The angle is outside the circle. The angle is outside the circle. I do what? Subtract. So what would it be, Brandon?
104 minus 38 divided by 2.
Right. 104 minus 38 divided by 2. So that's going to be 104 minus 38 is 66 divided by 2, which is equal to 33 degrees. All right. This problem, we have to find x. A little bit different setup, but we can still plug it into our formula and solve. What's the equation going to look like that I need to set up? What's it going to be? Aaron? You have to speak up.
105 plus 115 divided by 2.
No. We don't add the angle and the arc. Abby?
You multiply 115 times 2. You get x.
No.
No, it's 105 minus x. Right?
Logan, you're close.
105 plus x.
Plus.
divided by 2.
Yes. It's plus. The angle's inside the circle, so we add, but it's 105 plus x divided by 2 equals 115. All right, and then we solve, so that's going to be 105 plus x equals 230. So x equals, subtract 105 from 230, you're going to get 125. X equals 125. All right, got it? All right. Okay. Now, we have an angle outside the circle. The 1's inside the circle, but this is the angle. The angle for 1 is this angle outside the circle. Right? So, before I can plug into my formula, I've got a little work to do. What do we have to do first before we plug into the formula? So one thing you can do to help you see is highlight the arcs that are intercepted by the angle. So in this, we've got this angle, which we know, 134, and the other angle that's contained by that, the other arc that's contained by that angle is this one. We don't know that, right? We don't know that arc. How can I figure it out?
134 plus 170 minus 360.
Right. All the way around the circle is 360, so I subtract what I know. That's what's left. So we've got 360 minus 134 minus 170. All right, so that's going to be 360 minus 304 minus 304. So that's going to be 56. degrees. So this red angle is 56 degrees. Right? So what? Right, we subtract. 134 minus 56. Is that all I do? Divided by 2. Divided by 2. So that's going to be 184, 178. 178 divided by 2, which is 88, 89 degrees. Questions? No questions. All right, I think that's it. Yes, we'll stop there.